Hello people, Christoph from this side. In less than 10 minutes I will show you how to connect OP Proportional SSR and what needs to be changed in Marlin to enjoy printing with advanced material. In another 10 minutes how this configuration works on the printer, which give you an idea how it will be in your case. Finally, the thermal stability of the printer in case of the bed in the range of temperature 100 and 300 degree and nozzle between 250 and 450 degree. All this because this printer is universal one. What does mean? It's for commodity plastic, engineering and advanced material, even those which were not invented yet. So enjoy! From warning. Before installing the device, carefully read manual. The devices supplied with AC 220-240 volts 50 Hz or 115 volts 60 Hz are life-threatening. Ask about help qualified person. Now I will explain you what we have on the table, because this is actually what you need to turn your printer into high temperature printer. So starting from 24 volts DC power supply, infrared heater, bed heater, 2 OP Proportional PWM SSR, motherboard, in that case SKR 1.4 turbo, however you can use different one, bunch of wire and JST 3-pin connector. I will show you how to step by step connect the lamp heater first, then bed heater, and we are starting from connection of the power supply 24 volts to our OP proportional SSR, to those two pins on the left side positive 24 volts and on the right side ground. Positive red, ground black, like this. We need PWM signal from the motherboard, which we connect to the proportional SSR, and for this purpose we're going to use pin 1.24, which nominally is used for LEDs. So you need to wire up the JST connector. The yellow wire is signal, the black ground. Simply plug in and connect two ends to PWM port. Polarization of this port is arbitrary, so it doesn't matter how you put the wire there. Select proper PWM signal range from 0 to 5 with jumper and 0 to 24 without jumper. And because signal at pin 1.24 is from 0 to 5, we should have jumper in. Now you can select proper mode on the switch. We have three programmable positions. The first position is to determine what kind of power supply you are using. Position off for 220, 240 volts, 50 Hz, and position on for 115 and 60 Hz. The second switch is used to define the output characteristics, which can be linear power in off position, or linear voltage in on position. The third switch is to set the range of PWM signal from 0 to 100% in off position and 25 to 75 in on position. This is to provide more linear response, as you may have some noise at low and high level of PWM signal. My choice will be 220-240 volts, 50 Hz, linear voltage characteristics, and signal range from 0 to 100%. Now we can connect output, and as you can see, you have two connectors for outputs. The polarization of this type of the load, the infrared lamp, is arbitrary, so it doesn't matter how you connect it. It's time for connection of the bed. All steps are almost the same. Just you need to take PWM signal from the bed pin on SKR 1.4 turbo board, and that is pin 2.5 located here. And also you need to remove the jumper on OP Proportional SSR, because right now we are working with PWM signal in the range 0 to 24 volt. Connect power supply. Red positive 24 volts left side, ground right side. So we need PWM signal from pin 2.5 on the motherboard. So two wires. Polarization is optional again. We connect to connector for PWM signal on OP Proportional SSR. Like that. Remember to remove jumper, because right now we are working with PWM signal from 0 to 24 volts. Select proper mode on the switch, and my position are number 1 off for 220-240 volt 50 Hz power supply connected to this input. Second position on for linear voltage characteristic, and the third position in the range of 0 to 100% in off position. In the configuration.h, find the PID section for the temperature control and just enable it. After installing a new heater, it's good practice to perform PID auto-tuning. Auto-tuning with OP Proportional SSR works the same as without it. Simply type command M303, select the temperature at which you want to make auto-tune and insert number of cycles. Thanks to that you will get the PID parameters. You may notice that the soft PWM scale is set to 3, so let's find this parameter. The nominal value is 0 and the frequency of PWM signal at this level is very slow, around 7 Hz. This allows zero-crossing SSRs work correctly because they do not operate as expected at higher frequencies. That also means the dual response of the printer and can cause inconsistency in set temperature. With Proportional SSR, you can simply increase the frequency by increasing the soft PWM scale and have better, more precise temperature control. In configuration_advanced.h, it's time to enable case light. And then change the case light pin to P1_24 because that pin we are using on the motherboard. Now the lamp intensity can be adjusted from the LCD's menu, and different level can be adjusted for each single layer in the slicer. That's all you need to do in the Marlin to turn your printer into high temperature printer. I'm gonna show you how it works on the printer. We have two OP proportional SSRs. Left one connected to the bed heater in version 1, and the right in the updated second version connected to the lamp heater. If you are curious about the difference between the generation, please leave a comment. It's time to turn on the printer. You can see that red LED indicates AC live power supply is on and DC power is being supplied, and the green LED indicates that the logic is powered correctly. Now it's time to turn on the heating lamp, and you can do that by command M355, which allows you to control case light. The S parameter, value 1, turns infrared heater on, 0 off. P parameter is a PWM signal level, P255 is 100%, P128 50%, P64 25%, and so on. And of course, this can be done not only in printer phase, but also from the LCD's menu or add in the slicer as a command. So it can be different for each single layer. This will give you complete control over a single layer like never before. Let's test the bed connected to left SSR. The video is accelerated and slows down when the temperature reaches the set value. PID control lowers the voltage supplied to the heating element to maintain the temperature without extensive overshooting according to the PID settings in the Marlin. In the table you can find the time which is necessary to reach the adjusted temperature and also the time which is necessary to stabilize the temperature. In the end, the thermal stability of the nozzle, which is simply stable between 200 and 450 degrees. Thanks for watching. If you like the video, hit the like button, subscribe and link the channel. You can leave your comment below and tell me what you would like to see next time. If you want to support this idea, you can do that on Kickstarter. Link is below. Have a nice day and see you next time.